So you'll have to write these notes in your notebook. I don't like the notes packet and the way it's set up and the types of problems that are involved. So what we're going to do is go straight for the notes packet. Part 3, we're finally there to the final part of scientific notation. I'll be glad to see it go. I'm sure you guys will be too. But honestly, a lot of you have done a good job of improving and starting to understand it fully. Now we have some prerequisites we have to tackle. We're going to just look at adding and subtracting decimals to start. Whenever we add and subtract decimals, we have to line up the place values. So if we're going to add 1.2 to 301.5, we would line up the place values. 1.2 and add it, put the place value, right? The decimal holds the place value when we're in standard form, and that would be 301. And you want to be real careful to make sure all of your place values line up nicely. Now when we add that, we simply get 7/10. We add the 2 ones, and that gets us 2, 0, and 3, so 302.7. All right, so just remember that in standard form, we simply have to line up the place values. Now, be thinking about what determines the place value in scientific notation. If you can think through that, then you'll really be onto something. All right, now we just have subtraction, so let's do an example there. So we have 6.2. We're going to line up our decimals, and we have 0.051. Now we want to add some extra zeros at the end here so that we can subtract these two values. Now we're going to need to work our way over. We want this 0. We don't have enough there, so we have to borrow, but we don't have enough there, so we have to borrow from here. All right, so then we can borrow, make that a 10, but we have to borrow from there, so then this can become a 10. All right, now we are ready. We can subtract 10 minus 1 and get 9. 9 minus 5 is 4, 1 minus 0 is 1, and 6 minus 0 is 6. All right, so we have 6.149 as our answer there. Okay, so just a quick review. We have to be able to line up those decimal places to be able to add or subtract decimals. Now, distributive property, that's going to be the big property we lean on as we do this lesson. So let's review the very simplest explanation or example of distributive property. Distributive property says if we have addition grouped and multiplication outside of that group of addition, then we can simply distribute this to both of the terms inside. So what we get is we get 2 times x plus 2 times 3, which would simplify to 2x plus 6. All right, notice how we have a common factor distributed out to each. All right, that 2 that was originally here is now spread out to both of the terms that were inside the parentheses. Now, what we're going to do in this lesson more so is we're going to reverse it. We're going to look for the common factors, and we're going to pull that outside of the parentheses. So in this case, we could rewrite the 3x plus 9 as 3x plus 3 times 3. Notice how I rewrote the 9 as 3 times 3. All right, why did I do that? Well, I wanted to show you that these two terms have a common factor. They have a common 3 and a common 3. So since they have a common factor, we can actually rewrite them. We can take that common factor out and put it on the outside of the parentheses. And then we have the thing that was left behind and the plus sign, and that goes inside our parentheses. So x plus 3. All right, so the common factor comes out, and we're left with whatever was left over still being added in the parentheses. All right, so those are our prerequisite skills: understanding distributive property and understanding lining up the decimal places to add and subtract decimals. So now we're ready for adding and subtracting scientific notation. Let's do it. Okay. I am going to, let's see, I think what we need is just a little preview here. All right, I'm going to go over here. You can write in a little in the margins of your paper. All right, if I have, let's say, 6 times 10 to the third plus 2 times 10 to the third. I should have started with this instead of that first example. So this is like the preview to example 1. All right, now what we see here is that these two things that are being added have a common factor. So what we can do is we can pull that factor out, the 10 to the third, just like we did up here. We pulled that common factor of 3 out. We can pull that common factor of 10 to the third out. And what does that leave behind? That leaves behind the 6 plus the 2. Now think about distributive property like the regular way. If I distribute that to the 6, it turns into this. And if I distribute it to the 2, it turns back into this. So it's still equal, it's just written in a different way. All right, well, when we pull that factor of 10 to the third out, now the math becomes pretty easy. We get 6 plus 2, which is 8, and we still have the times 10 to the third on the outside. All right, so this would be our answer. And it is in scientific notation because that number is between 1 and 10. Okay, now we take it up another level. All right, we are going to be doing this problem here, and we're going to be noticing that, oh no, they don't have a common factor. They don't have a power of 10 that matches. So, have no fear. You have the skills to make them match. You can do it. All right, because we know if we make part of scientific notation smaller, then we have to make the other part larger. Or if we make one part larger, then we have to make the other smaller. So what we're going to do is, first step is make the exponents of the power of 10 match so we have a common factor so we can use distributive property. Let's give it a shot. Okay, so we're going to keep that first one the same, times 10 to the 5th. We're going to adjust this 10 to the 4th to be 10 to the 5th. Now, since we made that 10 to the 4th bigger, we have to make the 5 smaller. All right, so by one place value. So if the decimal was here after the 5, we just have to make it smaller by one place value. So we have 0.5 times 10 to the 5th. Now we have a common factor. So what we can do is we can pull that factor outside, 10 to the 5th. And what remains inside are the 2 and the 0.5, which is being added. So 2 plus 0.5. And then we simply, so that was, well, what did we do there? We did distributive property. Kind of the reverse of distributive property, but we don't have to say that. Do we just use distributive property? Now we can add that easy part there and get 2.5. If you need to, you can write it 2.0 plus 0.5. Line up the decimals and add them. 5 to bring down the decimal. Okay, so that's where I got that. And then we still have the times 10 to the 5th. Now, one thing you'll be confused about is like, wait, Mr. Woodworth, don't we like add the exponents or multiply the exponents or subtract the exponents or do something with the exponent here? No, we don't, because we just found a common factor and we pulled it out. All right, so that's the difference between adding, subtracting, and with all the other things we did, multiplying and dividing. All right, so there is our final answer for that problem. All right, I think you're ready for example 2. What did we do then? Sorry, we should just say what we did. Add 2 plus 0.5. And in the beginning, we had to get the exponents to match, right? And why? Because we want to use distributive property, which needs common factors to be able to do that. All right, so let's go to example 2. Notice the exponents do not match. We don't have matching exponents, so what we'll do is we'll keep the 3.1 times 10 to the 8th, and we'll adjust the other one. So we're going to bump that up to 10 to the 8th. So since that got bigger, we need to get this smaller. So that's going to be 2 oopsie, not 2. It's already 2, so it has to be 0.21 times 10 to the 8th. All right. Now we have our common factor. So we're going to use distributive property and pull that factor out, 10 to the 8th. And we're going to leave behind the 3.1, and that's going to be added to the 0.21. All right, and what did we do? That's called distributive. Okay, we're really undistributed the 10.8, right? The 10.8, the 10 to the 8th was in both of these, and we took it out. We undistributed, we stole it back, all right, and put it out here by itself. Oh, he's sad. He's lonely. All right, now we're going to add 3.1 plus 0.21, and we can do that right here. 3.1, line up the decimal, 0.21, put in my extra 0, and we get 3.31 times 10 to the 8th. There we go. Whew. I hope you're not too overwhelmed. But I've simplified these a little bit so that they're not such hard numbers to work with. Hopefully we can follow the process and do just fine. All right, now we're going to subtraction, which is just the same process, except once we undistribute the common factor, we're just going to subtract instead of add. All right. The 8 and the 7 do not match. We must get those to match. So we'll keep the higher one. Subtract, and we're going to change the lower one. So that's times 10 to the 8th. We want to make them match. So since this got bigger, we get to make this smaller so it stays equivalent. So that's going to be 0.41. All right. Now we're going to use distributive property, and since we have a common factor, we can pull that out, undistribute it basically, and we have the 6 minus the 0.41, and now we are going to subtract. So 6.0, I just added a decimal there, and I'm going to subtract 0.41. Put another 0 so I can have my place value set. I don't have enough in the first place value, in the hundredths place, so I got to go borrow, but I don't have any there, so I got to go borrow from the 6. So the 6 is going to go to 5. Now this can become 10, but then it has to become 9 because our hundredths place needs to borrow. So there we have it. We have 9, 5, and 5. So we actually subtract that, showing our work, and we get 5.59 times 10 to the 8th, and that is our answer. All right, guys, it's not easy, but you can do it. I believe in you.